Okay, hello again. Welcome to another lesson in Algebra 1. Today we're covering Chapter 1, Section 5, Exploring Angle Pairs. A warm-up. Draw an accurate and labeled picture of each. Okay, so our first one, AE intersects BD at point C. So this is our two segments, so we're going to use a ruler to draw this so it's nice and neat. Okay, so here's my first line, this line segment. This is line segment AE. Okay. And then I'm going to draw BD. So I'll just turn my ruler slightly. And we'll cut across here. And this is B and D. And they intersect at point C. So the place where they cross is point C. All right, angle ABC is an acute angle. All right, well, to do this one, we need to start with a line here. Okay. Put an arrow on one side because this is one side of our angle, so that's going to be a ray. And then we want an acute angle. An acute angle is any angle less than 90, so I can draw this angle less than 90 easily. Let's do the quick right angle test on it. Does it fit in the corner of the paper? And this would be definitely smaller. Okay. All right, so let's label this correctly. We need the B to be the vertex because that's in the middle of our angle. So here's A and here's C. And then to show that it's an acute angle, we're going to go ahead and measure it and put in the measure. Okay, so let's see what the measure of this one would be. And this looks about 24 degrees to me. So this will demonstrate that it is definitely acute. Okay. All right, number 3. The measure of angle RAT and the measure of angle CAT is 90. All right, so these two together make 90. So add them up and they make 90. So let's go ahead and draw one side of it. So I know I need a 90-degree angle. So I'm going to sit my protractor on here. If I can pick it up, there we go. And I'm going to turn it to 90, and I'll shrink it down a little so that I can make marks. All right, so 90 is about right there, and I'll put one of the angles here. All right, so it goes through 90, and it looks like 30. So I'll go ahead and draw these in. First thing I'm going to do is draw the 90. And then I'll draw in the 30. All right, so all of these little constructions take a little time to draw accurately. So please take your time and do it well. All right, so we know this is RAT. And then we'll put CAT right there. Okay. Now we need to show that they equal 90. So I'm going to put in our measures. So this is 30 for CAT. And this is 60 for RAT. And together those add up to 90. All right, so be careful here and make sure your two angles add up to 90 and that they share the same vertex and that T is in the interior of RAC. Okay, so be careful so that actually goes RAT and CAT when I look at the two angles. So number 4, if RA and RE are opposite rays. So opposite rays means they form like a straight line. So R has to be the endpoint of both. So there's RA, and here's RE. And they form opposite rays, which makes the picture look like a line. All right, we have a new definition down here, although I'm kind of thinking it's not new for most of you guys. Okay, so let's take a look at it. A right angle. A right angle, here's a picture of some right angles. Okay, here's 3 of them. What's the same about all of them? Well, there's a right angle. Here's a right angle, here's a right angle, and they all have a measure of 90 degrees. We could do our piece of paper test and slide it into the corners of all these, and hopefully it should fit perfectly. Here are 2 angles that are not right angles. Notice not 90 degrees. So a right angle has a measure of 90 degrees. All right, on the top of our second page, we have a definition here, another one. This is a pair of vertical angles. All right, so over here on the left, we have a whole bunch of vertical angles. So angles 1 and 2 are vertical. Angles 3 and 4 are vertical. And then it says angle AEC, which is here, is vertical to angle BED. And it also says that angles CEB and AED are vertical, so the red ones. Okay. So notice what's special about these. Let's look over here and see some non-vertical pairs, and hopefully we can tell what vertical angles are. So 1 and 2 are not vertical. 5 and 6 are not vertical. Notice there's a gap in between here. 3 and 4 are not vertical. And 7 and 8 are not vertical. So what forms vertical angles? Vertical angles are two angles whose sides are opposite rays. Let's talk about what that means. Now this is the definition in our book, but if you look in other books, you'll see different ones. So opposite rays here, so let's see how they're formed. So here are two angles. Let me erase this. 3 and 4. So here's angle 3 in green, and here's angle 4 in red. And I'm going to show you what they mean by opposite rays here. So this green one side, it goes with this red one. They form opposite rays. They make a straight line. And this green one goes with that red one. They form opposite rays to make a straight line. Same thing here. This blue one from angle 2 combined with the red one from angle 1 make opposite rays. And this blue one from angle 2 combined with this red one from angle 1 make opposite rays. And you'll see the same thing in the third picture. Now over here, some of these look like they might be vertical angles, but let's take a peek and we'll see. So this is one side of angle 3. Over here would be its opposite ray. That's why it doesn't work. Here's one side of angle 7, and over here would be its opposite ray. That's why it doesn't work. Here's one side of angle 5, and the gap in there means that the opposite ray would not touch angle 6. And here's angle 1, one side. The other side is angle 2, so that works out okay. But when I do this side of angle 1, it doesn't. It goes down here. Okay? So they're formed by opposite rays, and then we'll learn some more properties of vertical angles later. All right. A pair of complementary angles. So angles 1 and 2 add up to 90. Here's another pair, 3 and 4. What would those add up to? Let's see. The whole thing is 180. Together they make 90 because this part over here uses up 90. Angles 1 and 2 here do not make 90, so they're not complementary. These two do not make 90, they're 92. And these two add up to 180, so they're not complementary. So complementary angles are two angles whose measures have a sum of 90 degrees. Each angle is called the complement of the other. All right, and then snuck down here on the bottom is one more definition. An angle bisector is a ray that divides an angle into two congruent angles. So here's an angle, just freehand, and an angle bisector would divide this into two congruent parts, and we would show the congruent parts like this. Okay, the endpoint, its endpoint is the angle vertex. So the endpoint of that new ray is the angle's vertex. And within the ray, a segment with the same endpoint, so like this segment from here to here, would also be an angle bisector. So the ray or the segment bisects that angle. All right, let's flip it over. A linear pair of angles. So take a look at the pictures over here, and then take a look at the pictures over here, and see if you can think of what would make these guys on the left be linear pairs and the ones on the right not be linear pairs. So a tip-off in this problem would be this line linear. Remember in algebra we learned linear means line, so the definition part here of the name. So linear pair of angles. All right. So these two angles, 1 and 2, form a line when combined. Okay. Same with 3 and 4. 3 and here's 4 together. It's combined. They make a straight line. And then AED combined with BED forms a straight line, and the same with the other side. Okay, we'll draw that side in red. All right, so together they kind of make a straight line. If you look at 1 and 2, obviously together they don't form a straight line. It would need to go out like that. These guys look like they could, but they're not connected. So that's part of the definition. Notice over here, all of these share a common side. So in 5 and 6, they share a common side, but they don't make a straight line. 3 and 4, they share a common side, but they don't use this part that makes it a straight line. That's why they're not linear pairs. So a linear pair is a pair of adjacent angles. That means they have to share a side, whose non-common sides are opposite rays. The angles of a linear pair form a line, but another name for a line in geometry is a straight angle. Okay, so let's take a look back up here and see what we mean by that again. So we'll look at pair 3 and 4 here. All right, so 3 and 4 are adjacent. They share the side that's marked green and red. So this part right here is their side that's adjacent. Okay, and their non-common sides are opposite rays. So if you look at the non-common side, the red one over here and the green one over there, they're opposite rays. And opposite rays form a straight angle. And a straight angle is another way of saying a line. So that's what makes them a linear pair. Okay. All right. Pair of supplementary angles. The measure of angle 1 and the measure of angle 2 add up to 180 degrees. So these two add up to 180. 3 and 4 also add up to 180 because they form a linear pair, okay, or they make a straight angle with their non-common sides. Over here, 4 and 5 are greater than 180s. 1, 2, and 3 are not supplementary angles, even though they add up to 180. And 4 and 5, of course, are not supplementary angles. Okay, so supplementary angles are two angles, only two, whose measures have a sum of 180 degrees. So each angle is called the supplement of the other. So just like in complementary angles, even though we didn't say it, there can only be two angles that add up to 90. Now in supplementary, only two angles add up to 180. Now how do I remember complementary and supplementary? Which one goes with 90 and which one goes to 180? I think about the alphabet. C comes before S in the alphabet and 90 comes before 180 in the number line. So I know complementary goes with 90 and supplementary goes with 80. All right, let's flip it over and take a look at our last page. On here we have adjacent angles. Adjacent angles are pairs of adjacent angles. They share a common side, right? So angles have two coplanar angles with a common side, a common vertex, and common interior points. So we talked about adjacent angles already, and here's our formal definition. Okay. Postulate 1.9, a linear pair postulate. Remember, we don't have to prove postulates. If two angles form a linear pair, then they are supplementary. Now, why is that? Okay, let's see. Two angles that form a linear pair. Let's draw a pair up here. They form a linear pair because together they're supposed to add up to 180. So maybe this one was 45 and this one was 135. And they form supplementary angles because two angles that add up to 180 are always supplementary. Okay. All right, you can conclude from the diagram at the right. What can we conclude? All right. Well, let's see. I can conclude that angle 1 is congruent to angle 2. That's the only thing I can really tell from this part of the picture. Okay, and that's because of those little marks on there. That means that this ray right here is actually an angle bisector. Okay. I also know that the measure of angle 3 is equal to the measure of angle 5, and that's because they are, let's see, vertical angles. Let's erase here so we can tell it better. Okay. Here's 3 and 5, and those are vertical angles. Their non-common sides are opposite rays. Okay. And we could tell that angle 4's measure is equal to angle 1 and 2 together because those are also vertical angles. 1 and 2 combined make 4. It's vertical. Okay. Can you make a conclusion from the information in the diagram at the right for number 2? All right, so is each conclusion possible? Is TW equal to WV? Okay, this is going to be yes. These little marks show us that that's true. Is PW equal to WQ? This would be no. It looks like it could be. I mean, they look the same length to me, but there's no marks. If we knew that, it would have to have double marks on here. Okay? Is angle TWO a right angle? Well, it looks like a right angle. We could probably do the test on it and see. Maybe it would pass it, but we can't be for sure. If you want to really mark a right angle or know that it is a right angle, you need somewhere in words where it says it, or you need that little right angle, or you need a 90 degrees. So this would be no. Okay. And then TV bisects PQ. Does TV bisect PQ? Well, I can't conclude that either. TV is supposed to be the one that cuts PQ in half, but we have no marks to show that PQ is cut in half, so this is no. Now, PQ does bisect TV. So the other way, if I switch these two, that would be fine. That would be yes. Okay. But this way, this is saying TV cuts PQ in half, and it doesn't. We can't tell that from the picture. All right, our last problem here. Angle KPL and angle JPL are a linear pair, so we know that that means they form a straight angle together. And we also know from our postulate up above that since they're a linear pair, that those two angles are also supplementary. And that means that they should add up to 180. So the first one's angle is 2x plus 24, and the second one is 4x plus 36. And together they should be 180. If I combine them, I get 6x plus, let's see, that's 60 equals 180. And then I solve that, so 6x is equal to 120, and I divide by 6, and that would make 20. So I know the value of x. I got to plug that back into my formulas. So I know that the measure of angle KPL, we'll plug 20 in here, that's 40 plus 24, which is 64 degrees. And I know the measure of angle JPL, well, that's 20 times 4 is 80, and 80 plus 36 is 116 degrees. And notice if you add these two together, we get 180. All right, I'll see you in class next time to practice some of this.